Oh, Sanjana sounds with echo, right? Okay, right. So welcome to our lecture. So let me share my screen. Hold on. Can you see my screen, class? Can you see my screen, class? Can, right, thank you. Okay, so I will begin with today. Our main focus is on chapter 4, right? So just a recap. Okay, so this is, we are still in the project paper format. So now we are in chapter 4. So chapter 4, I have shown this last week, isn't it? You can put the title for your chapter 4 as research findings. Okay, right. So I will divide today's lecture into 3 parts. The first part, I will explain the concept and requirements under chapter 4. And then I will go through the steps, all right, on SPSS and eViews. And finally, using the student sample work, I will show you how to do the reporting of the results. Okay, so this slide, nothing much lah, just the heading. So we'll go into the requirements first. So requirements, first I will base on this slide, the measurement slide. So measurement slide, the earlier part, variable measurement, I have actually, there's another slide which talk about the same thing, right? All the nominal, ordinal, interval, and ratio scale. For SPSS, you will need to know what is the difference among these scales, because later when I show you the SPSS, the first thing when you key into your SPSS, you need to identify for each of your question which scale you're using. Okay, so you have to look back at these 4 scales. Okay, but today my focus will be on chapter 4 itself. What should we report under chapter 4? Okay, right. So the first thing you have to report in chapter 4 is descriptive statistics. Okay, so what are you going to, what are the important things to report into your descriptive statistics? Okay, you will have to produce a table that looks something like this, but later on, when I show my students' work, we will specify further. But basically, there are 3 important areas in descriptive statistics that you have to explain. Okay. Okay, and then you are going to put a heading like this, like table. If this is the first table in chapter 4, you will name this as table 4.1, descriptive statistics. Okay, so in the first column, you will put your variables. Rightfully, the heading here should be variables. So it depends in chapter 3. If your variables, you have given symbol to them, you can continue using the symbol. If you decide to put your variable in the full name, then you will put the full name here. Okay, so normally we will start with the dependent variable, followed by the independent variable for secondary data. If you have control variables, followed by the control variable. Okay, so what are we going to report under descriptive statistics? Firstly, will be frequency. Frequency is denoted by this second column, N. N stands for, or you can put it as a number of observations. You notice journals, sometimes they put the word OBS. OBS stands for observation. Number of observations. For example, for questionnaire survey, if 300 respondents have filled up your questionnaire, so your observation will be 300 lah. Okay. But for secondary data, because you're using panel, so it depends. Let's say you're using 100 companies, 5 years. So it may look like 100 times 5. So you may have your N as 500 here. But this will be generated by the software. So you don't have to manually calculate this. Okay. Secondly, will be measure of tendency. All these are statistical terms that you should have learned under basic statistics class. Tendency is measuring like what is the middle point and the most popular one we'll use is mean, mean or arithmetic mean, right? And then measure of dispersion. Here, minimum, maximum, deviation is standard deviation, and variance. But normally, we only report minimum and maximum, which is the range, and also standard deviation, because variance is actually related to standard deviation. So there's no need to report 2 times. So normally, we report standard deviation. Okay? So all these things, remember, when you have key in your data properly into the software, later there's a command where you can ask the software to generate these descriptive statistics for you. So you don't need to calculate it by yourself. Okay? So that is descriptive statistics. Now, for survey, besides descriptive statistic, you will need to produce a second table, but not this one. The second table is on the demographic profile of your respondent. When I go through my students' work, I will also show you a sample of journal, right? How to report the demographic profile of the respondents. Okay, but it's not this one. This one is still on variables. So we'll keep that in view. Right, so here is a bit more about what I've just mentioned. Measure of tendency normally is to show the midpoint. So if you remember in your maths or statistics class, normally the 3 measure of tendency are median, mode, and mean. So normally we will report mean. It is okay to report median, but so far I don't see research reporting on mode. So mean, median, that is fine. But the most popular one will be mean. Okay? Measure of dispersion, as I've mentioned, the most popular one. The range, we will report the minimum value, maximum value, and also the standard deviation. Okay? Now, this table is a very important table. Okay? So when you carry out when you run your data, and also when you want to report your results in chapter 4, please follow this checklist. If you look at this checklist, it tells you what are the tests or what are the areas that you need to include into chapter 4. And you notice I divide it into for primary data or survey, secondary data using cross-sectional. Cross-sectional means only 1 year data. I don't think this year we have this anybody doing for 1 year, right? But we have secondary data using panel. A panel means you use 3 years, 5 years or longer. Okay, so I think I'll focus on primary data and then panel data. So make sure you notice for different type of study, what you have to test and what you have to report in chapter 4 are not the same. Okay, like for survey, do you have to report all these things? For panel will be all these things. Okay, so what I have mentioned so far are the first 2. Descriptive statistics, whether you use survey or secondary data, everyone have to report your descriptive statistics. Demographic profiles of respondent, as I've mentioned, only survey. You have demographic profile of respondent. Okay, so normality test, reliability test, all these are diagnostic testing. Okay, together with multicollinearity test, then you have this heteroskedasticity, autocorrelation. All these are called as diagnostic testing. Okay, so we'll go into each of these tests, right, in concept now, and later using the software and then the reporting. Okay, but we'll keep looking at this table from time to time. Right. So first I will talk about the concept of normality testing, right here. Normality testing, basically, you have to do this. You can see normality testing must be done for survey and for secondary data. Basically, you want to make sure your data, what is the distribution of your data. Ideally, we want our data to be normally distributed. Normally distributed, you should have learned in statistics. Normal distribution, meaning your data will look like a bell curve like this, isn't it? This is normally distributed, and this is the mean, right? The expected results, and your left-hand side and right-hand side of your mean must be symmetrical, meaning it must be exactly the same. So this is normal distribution. So we want our data to be normally distributed. So how to test whether our data are normally distributed? Again, it depends whether you're survey or secondary data. For survey, you'll be using SPSS software. Okay, survey using SPSS, there are multiple normality tests, like what I've stated here. Number 1 to number 6, skewness, kurtosis, histogram, QQ plot, Safarov-Wilk test, Kolmogorov-Smirnov test. All these are tests of normality, right? Later when I show the software step, you will notice the software will generate all these results. So we'll go through it later. For E-views are more restrictive. Normally, we will look at the Jack-Barra test. Okay, right. So now I want to emphasize a bit more into skewness and kurtosis. Actually, E-views will also generate skewness and kurtosis. You can also look at it as additional normality testing. Okay. Now, what is the difference between skewness and kurtosis? Both are measure of normality, but they are looking at different things. For skewness, we want to look at whether our distribution is symmetrical or asymmetric. Symmetrical, as I've mentioned, the normal distribution will look like this, and then the left hand and the left side and the right side must be the same. So if it's not the same, then we say, for example, here you can see the data distribution. It is skewed. It is not in the middle, but it is slanting. You can see flatter to the right-hand side. And then it is steeper to the left-hand side. So this one, we call it is skewed to the right. Flatter to which side? We call it skewed to the right. Okay? Right. So that will be not so normally distributed lah, right? Whereas kurtosis, we are looking at the thickness of the data. Okay, thickness of the data is referring to the top of the normal distribution. The normal distribution, you notice the top is smooth one, very smooth like this, not flat, but it is rounded, but then it's not pointed. So if this kurtosis is not normally distributed, you notice when you run your software, your distribution will either be flat, like a rectangle or square, right? Or it can be very pointed, like a triangle. Then it is not, it means something is wrong with the kurtosis, okay? Right? So whether skewness and kurtosis, the perfect one, when you generate the data, it should be around 0. So the value for skewness and kurtosis, you notice when you run your data, sometimes it can be negative, sometimes it can be positive, right? But the question is, must it always be perfect 0? It is quite unusual that our data can be perfectly 0. So sometimes when the range between negative 3, positive 3, or some say negative 2, positive 2, can still be regarded as normally distributed. So this is the part later on, all these things, to know the range and all, you need to find who says that. So, but journal normally will have that. So I want you to look at what is the acceptable range and then cite the proper journal or the author that claim. Right. So if it's not perfect 0, how much is the negative and positive range that is still regarded as normal distribution? Okay. So that is normality testing, right? So, right. So we have done on normality testing. Okay. So far, any questions from your side? I hope you can follow, right? Okay, carry on. If you have questions, you can ask along the way. So now I will move on to another set of slide statistics. right? We still have other tests to run, but along the way, I will explain lah, right? But before we go further into the other diagnostic testing, right? If you look at this slide, class, right? This slide will talk about the rest of the testing, right? But before we go further into the testing, very importantly, is for you to know this concept of statistical significance, or we call it the p-value, right? If you read journal, they will always report the p-value, or they will say it is significant at what percent. Now, this p-value is very important, right? Because you can generate various statistics, but what does the statistic mean? Does the statistic hold any importance or not? It depends very much on your p-value, okay? So we have to understand properly how to read our p-value when our software generate the value. Okay, I will zoom into this slide. Okay, very important is what I've highlighted in yellow here. You can see this. So universally, right, you can see any research journal paper out there, normally we will have 3 level of statistical significance, we call p-value, which we will use as the benchmark. P-value at 0.1 means 10%, at 5%, at 1%. So when we want to know whether, when we run a certain test, when we get the p-value, we want to look at the p-value and decide, is our p-value statistically significant at 1%, 5%, or 10%? Okay? How we look at it, for example, right? Later, we'll look at the output of our software. If we get a p-value of 0.08, meaning 8%, so how to report it is statistically significant at what percent? We look at after 8%, what is the next highest value based on this benchmark of 1, 5, and 10%. So after 8%, the next highest value is 10%, right? So meaning 8% is still less than 10%. As long as any of the p-value is not more than 10%, it is still regarded as statistically significant. Okay? So, meaning if I get a p-value of 8%, I will report my results is statistically significant at 10%. Okay? Right. But what does it mean? If you remember in chapter 2, you have developed your hypothesis, isn't it? Right? And I've told you hypothesis got 2 types. Null hypothesis or H0, and alternate hypothesis is your H1, H2, and so on. But in chapter 2, you report only as the alternate hypothesis. Example survey, you got 5 hypotheses, H1 until H5, we report it as alternate hypothesis. So normally, alternate hypothesis will state that you expect the relationship to be either positive or negative between your IV and your DV. So this p-value is important because now we want to decide, for example, you run your regression, you want to test the relationship between your first IV and your DV, right? And you notice the results say p-value is 8%. So you want to know, so what happened to my hypothesis? So as long as your p-value is statistically significant, whether at 1, 5, or 10%, meaning we will reject null hypothesis. Reject null hypothesis. Null hypothesis, if you remember, always say there is no relationship between your IV and your DV. So when you reject null hypothesis, yes, sorry, anything?
一个一个来啊，雪晴，因为刚刚只是雪晴到了吧
I think he forgot to mute his mic, is it? Should we help him to unmute? Oh, did he mute already? Okay, right. Accident do happen, right? Okay, where was I? Right, here. Right, okay. So meaning here, if let's say I test the regression results between my first IV and my DV, and I found that my p-value is 8%. So 8% is still below the first benchmark, right? 10%, meaning my results is statistically significant at 10%. So what does it mean when my results are statistically significant? Meaning I will reject my null hypothesis. So as I mentioned, null hypothesis always state that there is no relationship between your IV and DV. So when you reject null hypothesis, you're saying your null hypothesis is not true lah. So meaning what is true? So we will say we do not reject our alternate hypothesis. We never say accept one. Do not reject your alternate hypothesis. In other words, we are saying our alternate hypothesis, like let's say H1 that we write in chapter 2 is correct. So meaning, for example, let's say in your H1, you wrote there is a positive relationship between your IV1 and your DV. So based on this result, we say we can conclude there is a positive relationship. And this positive relationship is statistically significant at 10%. Okay, so meaning we prove that there is a relationship. Okay, but whether positive or negative, actually you can't see from the p-value. Later, I will show you how to look at the sign. It can be significant, but whether is it in the correct direction that you predict, you can't see from here. You will look at another statistics. Okay, so we go to the second one. If p-value is 3%, so 3% is lower than 5%. So I will report as statistically significant at 5%. So again, as long as it's statistically significant, we reject null hypothesis or we do not reject our alternate hypothesis. If I get a p-value of 0.005, or in other words, 0.05%, meaning it is less than 1%, so we say statistically significant at 1%. So same thing, as long as statistically significant, we will reject null hypothesis. But what about the fourth case? P-value is 15%. 15%, if you notice, the maximum, the benchmark given to us is 10%. But 15% is already more than 10%. So our conclusion is this relationship is not statistically significant. So not statistically significant, now you see, different already. We do not reject null hypothesis. Do not reject null hypothesis, meaning we say that our null hypothesis is correct. And null hypothesis say there is no relationship between your IV and DV. So meaning, if you get not statistically significant, meaning in other words, what you try to prove in your chapter 2 is not true because there is no relationship. Okay, so that is how we interpret the p-value. Okay, any questions so far? No questions yet. If you have questions, you can ask or you can type into the message box, right? I can continue. So very important is to know how to read the p-value. Okay, next. Okay, now we continue with some of the reporting and the diagnostic testing. So one diagnostic testing that you have to run here, you can see, reliability test with KIV first. Correlation analysis. You have to test. You have to later ask your software to run the correlation analysis, whether you're using survey or secondary data. Now, when you run your correlation analysis, the results you get, there are two important things to do with the results. Okay? First thing, you must do your univariate analysis. Later, I will show based on my students' work, what do we do with univariate analysis. Okay. Secondly, you have to do a diagnostic test to test for multi-collinearity. Okay. So now I want to talk about diagnostic testing. So just now, the first diagnostic test is our data must be normally distributed. So we look at normality test. Next, we want to make sure our independent variables are not highly correlated. So what do? We will use the correlation analysis to do a multi-collinearity test. Okay, right. And later you'll see why I put variance inflation factor. To test for multi-collinearity, the first test is correlation analysis. And an additional test, this is optional, is to test for what we call in short is VIF. Okay, but the main test is multi-collinearity test. Okay, so now I'll talk a bit about correlation analysis. Correlation analysis, I think something all of you should have done, I think under basic maths or statistics. Correlation is actually, I think in finance, we learn a lot, isn't it? Whether the return is highly correlated, not correlated, and so on. So basically, it's looking at the relationship is actually not a very correct word, because to test relationship between variable, the proper test is your regression test. But this one is basically to see how the two variables, the value, how do they move? Do they move together or do they move in opposite direction? Okay, so when they move together, like x is my IV, y is my dv. If the value of my IV increase, the value of my dv also increase, meaning they move in the same direction, go up, or it can be both decrease, then we say there is a positive correlation. Okay, but if they move in opposite direction, one go up, one go down, then we say there is a negative correlation. Okay, so when you do your univariate analysis, basically you want to see the correlation between your IV and your DV. Is it positive? Is it negative? And also, is it significant or not? Okay, right. And how to use it for multi-collinearity testing later on. Later in the slide, they will when we talk about more about diagnostic testing, we will revisit the correlation analysis. Okay, but before we go into any of that, let's revisit your chapter 3. Everybody have draw your model specification, isn't it? This is the general model, okay, where all of us have written the equation, isn't it? Where over this side, left-hand side will be our dependent variable. We say equal to the intercept plus, we will put all these B2, B3. All these are called as the slope coefficient. All this B is the slope coefficient. And then X1, X2, all these are our independent variable and also your control variable. And here they use U, but normally we use the word E, right? E is the error term. So just now I've mentioned, we learned already what is P value for, isn't it? P value is when we test, when we run our regression, we will test, for example, what is the relationship between our DV, we call it Y, and our, let's say, our first independent variable, this X2 here, okay? Right. There are two things we want to test. Number one, is the relationship positive or negative? How do we know? We look at the B, the slope coefficient. Later, when you run your software, the software will generate the value for the B, and then it will tell you it's positive or negative. That is how we know the relationship between your X and Y. Is it positive or negative? That's the first thing. Secondly, we have to know, okay, like in this case, if come out positive, yes, there's a positive relationship. But is the relationship significant or not? That's where we also look at the P value, right? What we want is the sign here, hopefully it will be consistent with our hypothesis. Let's say our hypothesis H1, we expect there is a positive relationship. And here come out the B is really positive, and then the P value is significant. Then we say our hypothesis is supported because it is positive and it is statistically significant. Okay, so that is what we want to see. What we don't want to see, but if it happens, what can happen, what we don't want to see. If the slope coefficient, the sign turn out to be opposite to what we predict, like in our hypothesis development, let's say we expect H1 is positive, but when we run the data, come out negative, opposite sign, okay? Opposite sign. So it didn't go according to our hypothesis, right? Another possibility is it can either be positive or negative, but the p-value is not statistically significant. So we are saying there's no relationship. So either way, whether the sign is opposite compared to what we predict, or if the p-value turn out to be not statistically significant, meaning we are saying there is no relationship between our IV and DV, then that means our hypothesis is not supported. That is how we interpret it. Okay? Right. So that is how we look at the regression. Okay? So all this you have seen before, right? Now we go back to the diagnostic testing. So there are, besides the normality test, right, there are 4 important tests to run, but that depends on whether your data is primary or secondary data. Okay, if we look back at the table, multicollinearity, as I've mentioned, whether you are primary or secondary data, you must test for multicollinearity. Okay, but what about the test for whether our residual, we say, is homoskedastic, no autocorrelation, that one is only for secondary data. Take note, you look at this. Multicollinearity, all students, primary, secondary, you have to test it. But since for autocorrelation heteroskedasticity test, it only apply to those using secondary panel data. Primary data, no need. You notice what I tick means, what you have to do. And for the regression result, you see, for panel secondary data, before you run your final results, you must test for hetero and autocorrelation testing. Okay? Right. And when you run the test, you run it according to this sequence. Don't jump. Some, I notice when you present your result, you don't follow sequence one, right? So please follow the sequence from top to bottom. Okay, so now I want to talk more about multicollinearity, heteroskedasticity, and autocorrelation testing. Okay. Right. But before I go into all the tests, you notice when you run your results later, there are a few statistics that will pop out, and a few of them is important for us to report and interpret. And one of them is the R square, or we call R square actually stands for goodness of fit, okay? Or R square is also known as coefficient of determination. This one you have to report, whether you're primary or secondary data. Now, your software will generate the R square, but what does it measure? It measures the overall is a measure of the goodness of fit of your overall model. What do we mean by goodness of fit? Goodness of fit means the R square, what is measuring is the percentage of total variation in your DV that is explained by your regresses. Regresses is an alternative term for your independent variable plus your control variable. So what it means is your R square, you notice the value generated can only fall between 0 and 1. Let's say my R square is 0.9. 0.9 means 90% of fit. The higher is the R square, when it's closer to 1, the better it is. Better it is, why is it the better? It means based on our independent variable and your control variable that you put into your model, it can explain 90% of the variation in your DV. Very good, meaning you are putting in the right variables. That's why based on your limited IV and your control variable, if your R square is 90%, it means it already capture or it already explain 90% of the results you see in your dependent variable. Okay, meaning it's a good model, right? Because it capture the correct variables. But if your R square is very low, you come out 5%. Wow, 5% is very close to zero, meaning your goodness of fit is quite poor, meaning your all the variables, your IV, your control variable you put in can only explain 5% of the results of your DV. Meaning you're saying another 95% should be explained by other variables that you didn't include in your model. In other words, you are not putting in the right variable. That's why it cannot explain the results in your DV. So it's a poor model. Okay, so that is one thing we will see. Did you put in the right variable? Okay, so this one must be reported. Later I show you how to report. Another statistics that will come out from your software output is the F-test. F-test is another additional test for the goodness of fit of your model. Okay, so this one you can report as well, right? This one later in the software output, I have that now, so I will explain further. But basically, when you get the F-test, the statistics doesn't tell you anything, but you look at the p-value. If your p-value is less than 5%, then it is good. We say that our model is a good fit. If it's more than 5%, we say it is not significant, so it is not good. Okay, later we'll revisit the F statistic. Right. So now what we are interested in will be the 3 diagnostic testing, multicollinearity. So actually, what is multicollinearity test for, right? We will look at multicollinearity test, is we look at, it must be based on the correlation table, correlation analysis, and we look at the correlation coefficient among the regressors only. Regressor, remember, it means your independent variable. So multicollinearity testing is looking at the correlation between one IV and another IV. IV also include control variable. So your secondary data, you may have one IV, but you may have 5 control variable. They are all together known as IV or regressors. So we want to look at the correlation coefficient between every pair of regressors or IV. And we don't want the IV to be highly correlated. The reason behind that, I won't spend too much time explaining, because that, if you're interested in all these things, why the IV cannot be highly correlated, all these things, actually, if you have taken econometrics, it will provide you with the explanation, the reason why it shouldn't be highly correlated and all. Okay, but here I will just tell you what to test, what to look for, and then the conclusion, okay, without going deep into the rationale and justification. So, as I've mentioned, the regressors should not be highly correlated. But how do we know what is high? We look at the Pearson correlation. If the Pearson correlation between the 2 regressors or IV are less than 0.8, then we say it's okay. No multicollinearity problem. But if your correlation between any of your pair of IV is more than 0.8, then we have a problem. We say there is multicollinearity problem. Okay, right. Now, one thing to take note, going back to all the diagnostic tests, from normality, reliability, later this I'll talk about it, correlation, multicollinearity, hetero-auto testing. At every test that you run, if you notice there is a problem means you run your normality test and you find that your data is not normally distributed, you have a problem. You should solve the problem, meaning you don't just report, yeah, my data got normality issue, full stop. No. The reason with diagnostic testing is you want to detect the problem in your data set and you must solve the problem. Meaning from let's say you got normality problem, you must solve it to the point there is no more normality problem. Then only you can move on to the next test. Don't just report happily. You leave it there, you will be penalized, because meaning later you run your final regression result, that result is not an acceptable result because it is still full with statistical problem. Okay, so remember, every step got any of the diagnostic tests that are not, you don't pass, you must solve the problem. I will go back shortly into how to solve normality problem, but now we are in multicollinearity. Similarly, so if you run your multicollinearity test and you find that any set of your IV is more than 0.8, got multicollinearity problem, you have to solve it. Okay, but the question is how to solve it. Again, shortly, I will talk about how to solve the problem. So, as I've mentioned just now, another test you can run for multicollinearity testing is variance inflation factor, right? Normally, the software will generate, but I think in the printout I given on the software step, I didn't show you, right? But you can easily search for the function. If you can, report it as well, if you can find the function. If not, you just report based on correlation, okay? So if you want to go the extra mile to report on the VIF, the benchmark is the combined VIF. You notice when you run the data, they will run the VIF for every IV and DV, and then there will be a mean VIF. Mean VIF means average VIF for the whole regression model. That mean VIF should be less than 10. Less than 10 means okay, no multicollinearity. If got more than 10, we got a problem lah. Okay, so that is multicollinearity testing. All right. Now we go into remedial measures. So what should we do if, after we run our multicollinearity test, for example, using the correlation analysis or using VIF, how to solve it? As I mentioned, you must solve the problem. You cannot leave the multicollinearity problem unresolved, right? There are a few ways to solve the problem, right? One easy way is you just drop, remember that multicollinearity means two of your independent variables are highly correlated. So one solution is you drop one of the IV, meaning throw out one of the IV from your regression model. But that can be a problem because, like, let's say what happened, these two IV are your main IV. Maybe it is part of your objective to study these two IV. Then it is very difficult for you to throw out anything. Like, let's say you're doing survey, right? You have 5 IV. And when you run the correlation analysis, you found that the two IV are highly correlated. So it is very difficult to throw away one of the IV because you say, then I end up with 4 IV, then I got 4 objective only. If that IV is very important, we cannot simply exclude them. So what do we do as an alternative so that we still will consider all the IV? We will split the regression model into more than one model. Okay, meaning let's say IV1 and IV2 are highly correlated. You will run them separately, meaning you don't put them in the same regression model. You understand? So meaning IV1, you run it maybe together with other variables, IV2 with other variables, but you don't run them in the same regression model. Okay, so that is if your IV are important IV. But for secondary data, let's say the problem exists between your control variables, right? Because control variable are also your regressors. And let's say two of your control variable, let's say macroeconomic data, inflation rate, interest rate. If you put them together, normally they are highly correlated, but they are just your control variable. So control variable are not so important, isn't it? In that case, you just drop one of the control variable. You don't need to split the model. You choose which one you don't want. Inflation rate or interest rate, you just drop one of them. Okay, so that is the solution for multicollinearity. So you have to solve it before you run the final model. Okay, so that is multicollinearity. Any questions so far? Not yet, right? But are you following so far? Let me get some feedback. Can you follow what is going on so far? Now we are just going through the concept. Can. All right. Thank you. Right. Thank you for your feedback. Right. I'll continue. So next will be the diagnostic testing for secondary data. We have to test for heteroskedasticity and autocorrelation. And again, if there is hetero problem, auto problem, we must solve it first before we can run the final regression results. That's why you see this table has a logical sequence one. Okay, you will test for these two first, solve any problem. When got no more problem, then only you can run your final regression results. Okay, so let's look at hetero and auto testing. Right. Right. So for those who have not taken econometrics, you may be wondering, so what is this hetero auto thing? Right. Again, I will mention very briefly because I think if you have taken econometrics, one chapter alone is hetero, one chapter alone is auto. So it's actually very lengthy one, right? But I will do it in one sentence, definition. Right. So what is heteroskedasticity in brief? Basically, what we want our model to be is homoskedasticity, right? So if it turn out to be heteroskedasticity means it is not good. Homo means same, right? Meaning we are looking at our error term. If you remember error term, our E or we use U. Our error term should be constant. When it is constant, then we have a situation of homoskedastic. That is what we want. But when it's not constant, we have a problem called heteroskedasticity. Okay? And how to test for this heteroskedasticity, right? There eViews provide you with multiple testing, but the two most common tests will be the one I've highlighted in red. Okay? But in my software later, I will only choose I think one only to test. But the common test will be either you use your Brugsch-Pagan test or the White's test of heteroskedasticity to detect whether there is any heteroskedasticity in your residual. Residual means your error term. Okay? So that is to detect. And let's say after you run this test, you found out, oh, really, there is hetero problem. So how to solve the problem? Remember, every diagnostic test, if you cannot pass, you must solve it, right? So what should we do if we detect heteroskedasticity? The most common one, we will do this one. This is what I will do later also. We will use the White's heteroskedasticity consistent standard errors, or we call it robust standard error. And how to do it is actually very easier. This one I will show you later, how to correct for heteroskedasticity. Okay, so we will test for hetero first and then correct it. Then only you test for autocorrelation. So what is this autocorrelation? So normally autocorrelation happen because you're collecting data for more than one point in time. Let's say like you're collecting panel data for 5 years. So autocorrelation may happen because the error term between one observation and another observation, the covariance, right? If it is not zero, like it's rightfully supposed to be zero, Zero means no autocorrelation. But if the covariance between one error term and another error term is not zero, then we have autocorrelation. Okay, right? So normally it happens when your data covers more than one point in time. So we have this autocorrelation problem. So how to detect the problem? Again, eViews provide you with a few tests, but the common test will be either you use the Durbin-Watson test or you use the Brugsch-Godfrey test. Okay? And if you detect there is autocorrelation, what to do? Here, the slide never show you, but you notice in your Google Classroom for lecture, I've uploaded 2 video, YouTube. One on how to solve hetero, another one how to solve auto. These 2 are very good video. They are not by me. You notice they are by other people. But I run through many YouTube channels. And these 2 are the one that, to me, the methods used are simple to understand. And they give you various solutions. So normally students, after they try many of these suggestions, most of them will be able to solve the problem using either one or more of the techniques suggested. Okay, so here I didn't list it, but one of the method used is we use the AR, auto-regressive method. That is what I will show in my software output as well. Okay, but for more method, please look at the YouTube. Okay, right. Okay. Now, now I go back to normality. If you look at here, so actually I've talked about all the important tests except reliability. Reliability, I will talk about it when I go through the SPSS output later on, where you test using your Cronbach alpha. But going back to normality test, just now I teach you how to test, what tests we can use for SPSS and eViews. But what happens if you have normality issue? How do we address or solve the problem? So normally, why your data set is not normally distributed, not a bell curve, most of the time, it could be because of the presence of outliers. Outliers means extreme value, meaning your data, let's say you're collecting data for anything lah. Let's say for you calculate the ratio, return on assets, return on asset. Let's say all your data maybe is between 1%, let's say the most also, let's say maybe 30% ROA. Suddenly, one of the data is 1,000%, right? Meaning the value is extremely large, or it can be extremely small, negative 1,000%. That is what we call as outlier, right? The data is extreme compared to all other data which appear to be in a normal range. So, how to solve for normality? Right. Okay. So normally what we have to do is you have to go back to your original data set. Normally we will key in the data set depending. If for secondary data, normally we will start by keying in the Excel. Later we will copy paste to eViews. For primary data SPSS, we may key in directly into the SPSS. So whatever method you use, you look back at your data entry. 2 possibilities. One is why your data is not normally distributed. Why suddenly got this extreme value could be a data entry problem. Sometimes it's you key in wrongly, right? Instead of 10%, you go and key in 2 extra digit, become 1,000. That's why it become an outlier. So you have to look at all the value, which one look like very extremely big or extremely small. And then you must identify, is it data entry problem, or you calculate wrongly? Could be Excel, the formula suddenly something went wrong. So it is an error. Or it could be sometimes it's not an error. That particular company may be going through some extraordinary exercise, maybe merger or something happened in that year. That's why that particular variable, the value is extremely different. So in that case, what we will do is we remove the outlier. In eViews, the problem is when you remove, you have to remove the entire, I think you have to remove the whole company, right? Meaning you don't want to include this company with outlier, okay? So normally how we solve it, we remove the data set. But you will notice sometimes you try remove, wow, from 100 companies, remove until 80, still the data is not normally distributed. Then what to do, right? Okay, we have seniors, when that happen, cannot sleep, cannot solve how many more to remove because it's still not normally distributed. So we have to understand why. Now we look at justification. Why our data is not normally distributed? Two possibilities. One could be because our sample size is small. Remember, one reason why we want to get a big sample size is so that our data is normally distributed. But sometimes because you're studying like only on specific sector, I think some of you, you're doing only on financial sector, you are doing only on the transportation sector, plantation sector. So the size of your population or sample is quite small. When it's quite small, it is possible the data may end up not normally distributed. So in this case, you can't remove anything. Or maybe after removing a few, it's still like that. Then you explain, right? Provide your justification, meaning leave it as it is. You explain because your sample size is quite small, right? But if normal, your sample size is 100 and above, normally shouldn't be a problem one. So you must see what other reason that cause your data not to be normally distributed. It could be maybe the nature of the data for that year is really like that. Example, COVID-19. If you collect profitability data during COVID-19, you notice the data is not, the profitability is not normally distributed, but it may be skewed more towards, you see the higher point is losses, meaning on the left-hand side of your mean. Why? Because majority of company make losses during COVID-19. So you justify. You must find a logical and valid reason supported by journal, right? Like ROA, why it's not normally distributed, but let's say you collect during COVID-19, more majority show losses. But it is logical. You can support using literature that majority of firms, they suffer losses during COVID-19. So you justify, okay? So that is how you address the outlier problem, and if you cannot address, how to justify properly. But my warning is, don't everything data sample size is small. 100 to me is not small, so don't use that excuse all the time, okay? So that is how we solve for normality. Others are nothing much lah, all this no need, right? Okay, so that is in terms of the concept behind this table. Okay, any questions? No question. Okay, so if no question, now I will go into the software output itself. Software. So I will use the document that I've already uploaded called Testing of Hypothesis. So everybody, you can look at it together with me. You can make notes along the way. Hold on, I'm trying to drag my document. Okay. Okay. I give you in PDF form right now. So you look at this document. Hold on. Right. So I will go through based on this document, meaning the software, I will show you based on my print screen, right? Based on my print screen. Okay, let's see how it works, right? So remember, as what I've mentioned, what we want to do when we do our regression, our testing for our software is, we hope our alternate hypothesis will turn out to be true, right? When the p-value is statistically significant and we see the slope coefficient is according to the sign that we want, okay? Right. But if the p-value is not significant, then we say there is no relationship. Okay, like stated here. If our p-value is less than alpha here is significance level, like at 5%, 1%, 5%, and 10%. If it's less than that, then we reject H null. Reject H null means we do not reject alternate hypothesis. So we say our hypothesis in chapter 2 is supported. Okay. And I've also shown you if our p-value is more than the significance level, maximum is 10%, isn't it? Let's say our p-value, like just now, 15%, then it's not significant. So we say we do not reject H null. So we say there is no relationship between our IV and DV. So I hope this concept you understand very clearly, so that when you see the p-value, you know, is it statistically significant or not statistically significant, and what to do with your hypothesis. Okay, right. I will first explain the software for SPSS. I will look at first multiple regression, followed by logistic regression. Then only I will go into eViews. Okay, so SPSS first. So SPSS, as I've mentioned, I've gone through a few times on the scale, isn't it? I've mentioned normally we can divide scale into 4 types, isn't it? Early this lecture also I highlighted again, nominal, ordinal, interval, and ratio. But you notice your SPSS only asks you to choose one out of the 3 scale. Nominal, ordinal, but they don't put there interval and ratio, but they put it together, they combine, they call it scale. So meaning when you see the option scale, it is either interval or ratio. Okay, so you have to choose accordingly. So normally I would think, if I remember based on all your questionnaire questions, either is nominal or scale only. Nominal will be the one like, I think nominal you don't have a lot, right? For example, adopt, do not adopt. So there are 2 categories, right? Yes, no, right? So when it's categorical, nominal, ordinal we seldom use in finance. So I don't remember seeing any of the scale using ordinal. Your 5-point Likert scale, or you give them multiple choice question, then you add up the score, all those, they are called together scale. We will select the measurement called scale. Okay, so later you notice your SPSS will ask you to choose either one of the yellow one. Okay, right. Okay, so before I separate it into multiple regression or logistic regression, remember for primary data, one thing you have to test for is normality. So regardless of whatever regression you run using SPSS, you must test for normality, and the test is the same test. Okay, right. Okay, so here we try to understand this very simple scenario, right? So you can but of course in your project paper it is more extensive. Let's say we have a very simple situation where we just want to test the relationship between A and B. And our hypothesis, we expect A and B is positively related. Okay, right. So what we do in our questionnaire, we only have 2 variables. Let's say one is the IV, one is the DV. We use 5-point Likert scale as from strongly disagree is 1, strongly agree is 5, and then we have the set of questions for A and B, like how you do for your questionnaire. And let's say we collect data from 15 respondents, maybe because it's a pilot study, so 15 respondents, and then after we did this, we tabulate the score. Okay, right. Now you may ask, you're using 5-point Likert scale, but how come the score looks like this? Okay, so you see, I focus, there are 2 variables, isn't it? So my variable is A and B. Why I have all this? This is the answer given by my 15 respondent. If you count, there are 15 responses here, 1 for each respondent. So why is it, let's say I focus on respondent 1, why my A value is 176? Because if you remember, let's say A is your IV. In your questionnaire, you have more than one question, isn't it? Let's say you have 6 questions. Every question you test using the 5-point Likert scale. So this 176 is you add up the score for each question. Could be question 1, I don't know how you end up 100 over lah, right? But it could be many, many questions. Maybe question 1, it is strongly disagree, so 1 point. Question 2, strongly agree, 5 points. So I take 1 plus 5, for example, and I continue adding. So this part show you the total score. Okay, right. But you may ask, so in my SPSS, when I key in, do I key in just, I add up manually the total score, or should I add up the score for every question? Like variable A, I have 6 questions. Should I key in? I put A1, A2 until A6, question 1 until 6 for variable A. Preferably, you key in by question first, okay? Because later you see, when you want to run for your reliability test, your Cronbach Alpha, we want to know the breakdown of the question, okay? But most of the time, even though I key in, let's say got 6 questions under A, A1 until A6, meaning what I will do in my SPSS, I will key in A1, A2, A until A6, what is the score provided by my respondent, but I will also create a column called A. A will be the combined score, meaning I add up the score for A1 to A6. What is the score for each respondent? I do the same thing for my variable B. So yours, you will have more than 2 variables. So you do the same for other variable. Okay? So how are we going to test for normality? Okay. Now, this SPSS version is a bit old because actually I have this for quite a number of years. And SPSS, one thing, they are very innovative. They keep coming out with new version. So it might look a bit different, but still the general concept and function should remain the same. Okay. So if the layout is slightly different, don't be alarmed. Basically, it's still, you have to input more or less the same thing. Okay. So when you go to SPSS, you have to look for this screen, right? The data editor screen. Okay. This data editor screen is where you cannot key in all the values straight away. You must first, what can I say? For every of your variable, you must input the what is the correct description. So normally we only need to input 2 things. Okay. You need to input here the name of your variables, and then you need to decide on your scale, on your measure. Other things is by default, meaning you don't go and touch other area, no need to do. So you go to this data editor, you key in your variable. You can key in according to your symbol. Maybe you have symbol or you have full name of your variable. Whatever that you use in your chapter 3, you key in accordingly. So as I've mentioned, it's better to key in by question. Like for example, your first variable is A. You have 6 questions, right? You key in A1, A2 until A6, then A is the combined score, right? So you do the same for other variable. First, you key in the name of the variable, measure, and measure. Measure is the one, this one, you notice, is talking about this one. So you have to look at every question that you ask. Are you testing based on nominal scale, like adopt, do not adopt, or you use like 5-point Likert scale when you add up the score, that is called scale. For my case, like because these two are using 5-point Likert scale, so the measure is scale. Okay, so that's why here you see there's a drop down menu one. When you click on it, they will ask you to choose either nominal, ordinal, or scale. So in this case, for both my variable, I will choose scale. So once you did that, you can type something like, I think it's okay, like they always have the okay button one, right? You can see. you will come to this view. You can see at the bottom. First, I click my variable view. Variable view is to key in this one. After I'm done, I will click the data view. You see, data view. Then it will show me according to what I have instructed. Here, I've only instructed I got two variable name, isn't it? So here in my data view, right, it will appear A and B. Right. So once, for your case, sure got more like A1, A2, B1 until all your variable. So what do I do now? Now I can key in. I look back at every questionnaire. One will represent respondent one. So rightfully, you have 301 until 300. So I will key in the score for every question. And make sure you have one combined one where you add up all the score. Okay? So that is how you input into the data view. Okay? So far, any questions? No, right, carry on. Remember, here I want to test for, before I go to normality, here I can test for descriptive statistics as well. Remember, because one of the things I have to report for survey descriptive statistic. So I can generate it now, right? How do I generate descriptive statistic? I go to, you can see, wherever the yellow highlighted, meaning that is where I click. It's a window-based system, so it's very easy, just like how you use your Excel and so on. I click Analyze, Descriptive Statistic, the drop-down menu, I choose Explore. Okay? And then this window will pop out. So I have, remember, in my case, very simple, I got two variable only. When it comes to generating descriptive statistic, I don't want by question, I want by variable. So meaning that's why I will only look at the combined score. Okay, I won't click A1, A2, everything. I will click my main variable, the combined score. I only have two. I will choose both. I will, when you press this button, meaning your A will move into here. Then I highlight the B, I click this arrow button, it will go to the dependent list. So after clicking both, you see here, no more already. Both, I choose A and B. So in your case, for survey, you have one DV, 5 IV. So we expect here you have 6, right? So you click all your IV and DV, the total score, right? So after you do that, other things, you just keep it as it is. Normally, it's by default one. So all this, I never touch one. It is by default. So I click, I think, okay, right? Is it okay yet? Not yet okay, right? If not yet okay, you'll see, I will show you next. Okay. You may wonder where I get this. You can see here. You notice maybe very difficult, a bit difficult to see because here just the window pop out. So actually what I clicked was this one. Statistics. Because you notice explore statistics. So when I click statistics, it will pop out another window. You follow accordingly. You tick whatever I tick. The value, this is, I think 95% is by default. So you click what I click, right? Then I think it's continue. Click continue. Then what happened? Next one, plots. You notice plot, this one. Then I click on this one. Plot will come out. So tick according to what I tick, follow only. Then I press continue, right? Oh, no more continue. I think I finished already. Continue, then I think they will have okay lah because nothing else to click. So the final one will be okay, right? So once I do this, it will run the descriptive statistics. So you notice I will get output looking like this. And you may be overwhelmed. Wow, so many tables. This is only two variable. Remember, you got 5 IV, 1 DV. You will be, this thing you'll see 6 times. Right. So the question is, what is important for your analysis? That's why I've highlighted the important areas. Not all the tables are important. Right. So you'll notice the SPSS output, it will report according to your variable. My first variable is A, so it will report all the descriptive statistics for variable A, then followed by B. So if you have more, it will repeat lah until the end. Okay. So what I'm interested in, if you remember just now, I say I'm interested in mean, the value, the statistic value. I'm interested in standard deviation, minimum, maximum. Normally only this one lah, right? Others, normally journal, they don't report it lah. Okay, right? So I'm only interested in this few. Okay, right? Skewness, kurtosis, yes. Right, for normality, this one are my first two normality tests. So skewness, kurtosis, you notice, like what I've mentioned just now, it is very difficult to get perfect zero. If perfect zero, that one sure normally distributed. But you notice normally it will be either positive or negative lah. But what range is considered okay? I put here between -1 and 1 still normal, but actually it can go to -2 and +2 and -3 plus 3. You can actually widen it because some statisticians say it's still okay, but you have to cite lah which author says that it's okay to use +-2, +-3. Okay, right? So in my case, if you look at my skewness and kurtosis, it is actually between -1 and +1. So to me, it is still normally distributed. So it's still okay, right? So I will pick these few. But one thing to remember, when we write chapter 4, you don't be lazy, just copy and then paste this into chapter 4. No, right? Later, in the next part of this lecture, I will teach you, you have to extract the important information, like what I've highlighted. You have to create a different table. And that table will look like how journals normally present the results. So all these are just the initial output, but I still need you to copy and paste this into a separate document because when you submit your project paper, I need evidence of the original output. So all these you must attach in your Google Classroom as a separate file as evidence of your SPSS output. Okay, but in your reporting, never be lazy, copy, paste straight away. Okay, sure deduct marks for format not nice word. This is like, it's not a proper way to present the data. Okay, right. So remember, we will select all these. Later, using my student sample, I will explain how to interpret it. Okay, right. All these I've mentioned already, what is skewness and so on, right? I won't go into the statistical part. Interpretation, normally I won't follow this lah. I won't really follow this, but I will prefer to follow, maybe some I can follow, but this one is more like, if you attend econometrics or statistics class, they teach you lah. It's more of a textbook way of answering, but the one I prefer is like the journal way of explaining, okay? But we can still make use of some of these, like if I report the mean, what is it? What is the minimum, maximum, standard deviation? I can report something like this, okay? Skewness, you can take note how I report it. The data is skewed to the left. Why? Because it's negative, right? And then why kurtosis? I say flat and light tailed distribution because I got negative, if you notice. For A, if you notice, my kurtosis is negative. So if you want to know how to interpret, I think I have it here. If negative, right, what does it mean? Meaning it's piled to the right. If positive, piled to the left. No, just now was kurtosis. Here, right. Kurtosis, right. If positive, what does it mean? You can report, my data is pointy and heavily tailed, have a pointy and heavily tailed distribution. If negative, have a flat and light tailed distribution. Because mine is negative, you see, I recycle. My data, maybe for IV, has a flat and light tailed distribution. So you can make use of keywords like this. Confidence level, normally no need lah. For journal, for project paper, normally we don't need that. Okay, so you just follow back like what I've mentioned just now, right? The important one to report later on will be all this highlighted one. Okay, so that is on descriptive statistic, and for the first two normality testing, you use skewness and kurtosis. Okay, but I've mentioned before, for SPSS, there could be more normality testing, like what I've mentioned here. Here, you can see, I've mentioned SPSS, not only skewness and kurtosis, but I can also use histogram, QQ plot. What I'm going to look at is these two, Shapiro-Wilk and Kolmogorov-Smirnov test. Okay? Here, you can see, So the other two alternative normality tests for SPSS is Kolmogorov-Smirnov, Shapiro-Wilk. So when this test will be generated together with all the rest, what I will look at is, of course, for each variable, and I look at this SIG. SIG stands for significance level, meaning your p-value, right? P-value. Remember, any p-value that is more than 10%, the benchmark means not significant. Okay? So, but here, normally, for all these like diagnostic tests, we will use the cutoff is 5%. So meaning if our significance of p-value is more than 5%, we say that it is already not significant. Okay, not significant means do not reject H null. H null normally is normally distributed. So do not reject H null. You're saying if I get my p-value of more than 5%, meaning my data is normally distributed. So in both cases, you can see my p-value is more than 5%. So we are saying both my A and B are normally distributed. Okay, right. But you will also notice my case, you can get this. But normally when students they run for their project paper, they will find the p-value is less than 5%. Meaning not normally distributed. So what to do? You will notice you run all the multiple tests for normality. Sometimes the different tests will contradict each other, meaning like skewness and kurtosis may say normally distributed. The 5 and 6 tests say not normally distributed. It is possible the tests don't agree with each other. What are we going to do? Later I will explain. Okay. So in this case, mine all agree with each other because the data somehow we make it very nice for educational purpose. But when you do for your project paper, you see the real thing. You see all funny things sometimes. Okay. So this is the two tests. Histogram. Okay, this is called a histogram. Also, a test for normality, as stated here, histogram. Histogram is your bar graph. If a proper normally distributed, I think just now I showed, actually all this also not very nice. If normally distributed, my bar graph, if I draw, you will be able to see this shape. But if you see all the funny shape like this, or like this, skewed, or you see here very flat, or lagi flat, right? Or like this, it means, what can we say? You can see a bit of a shape of a normal distribution, but it is not a very good normal distribution. That's why I put here, there is some evidence of normality, but it is not perfect. It is not very smooth like a normal distribution. And if you base on histogram, what could be the reason? In my case, because I only have 15 respondents, so mine is really due to small sample size, right? But if you get this, you have to see what could be the possible reason. Because 300 respondents is not small, it is considered already quite acceptable already. So it must be due to other reason. Okay, so that is histogram. And the last test is the normal QQ plot. Okay, now this is how a QQ plot look like. Make it smaller so you can see the labeling. Right. you will notice there's a straight line. This straight line is the expected value, what you hope to achieve. And you will see all these dots here. All the dots are the observed, meaning the actual value based on what your respondents give you lah. Okay? So, how do we know for that variable the data is normally distributed? Normal distribution if the observed value, meaning all the dots are close to or they are on the straight line. Like in my case, some are on the straight lines, but they are all very close to the straight line. So in my case, this is normal distribution. Okay, right. Okay, then you do the same for B lah. B, you see the histogram looks better, isn't it? QQ plot still okay, but got a bit far away lah, but still okay lah, right? Okay, so the question is, I have gone through all the 6 normality testing. 2 questions. Do I need to report all the 6 tests? What happens if some tests contradict with each other? Okay. Number 1, it is not, if it's all normally distributed, okay lah, then very, very good. You report all the 6. But normally, using a real data set, you notice you cannot get all 6 that will be consistent telling you normally distributed. So what do? I will only select those output that show that my data is normally distributed. And normally it will be the first 4. 5 and 6, if you run and see, normally come back significant one. P-value is less than 5%. Okay, right. So we will report only those that show normal distribution. Okay, then we report accordingly. Okay, so that is for normality testing. Any questions? Are you still following? Can I get some feedback? Still okay, Right, okay, very good. Okay, can carry on, Right. All right. So, done normality testing. So, whether you're using multiple regression, logistic regression, same steps. But now we want to differentiate the 2 regression. For all the survey you do, right, except I think only for Pinlin's group, because you're doing adoption of BNPL. Pinlin's group, you're using the second one, logistic regression. The rest of you, because your IV and DV both are, meaning normally you test, you got the score, isn't it? Either because you use the Likert, the 5-point Likert scale, or you use a multiple choice question, doesn't matter lah. You add up, you got different value, isn't it? That is, if both your IV and DV is like that, we will run what we call as the multiple regression. Okay, you notice later, like for Pinlin's case, only one case, isn't it? Your DV is adopt, do not adopt. So this is categorical, nominal. So we need to run logistic regression. Okay, so this one will apply for all the survey except for the adoption of BNPL case. Okay, so again, I use a very simple case. So here we want to test the effect of various feed additives, meaning food lah. All right, what we put into the food on the time required in days to bring the beef cattle, meaning the cow lah, to market weight. So meaning these are farmers lah, right? They rear cow lah, okay? And they want to see, depending on what they feed the cow, right? How long it will take the cow to grow to the size lah that is marketable, okay? Right, and then they are looking at 3 possible food additives: protein, antibiotics, and other supplement, right? So when we look at this, so what is the IV, what is the DV? Our food additive will be the IV. The time required to make the cow to grow to the expected size is the DV. Why? Because what food we feed them will influence their the time they need to grow, isn't it? So I identify, I got 3 IV, 1 dV. And let's say I test on 18 cows. This 18 cow is like your respondent lah, right? But again, this one, the sample size is quite small. Okay, so I will, meaning this is, let's say, after I, like for you, you fill in the, ask your respondent to fill in the data. So this is how you look like. You got respondent 1 until 18. This is the score given. This is the combined score for every variable, right? So if I have all this, so what do I do next? Okay, so same thing. You always start with the data editor and you always go to the variable view. You key in the name of all your IV and DV. Remember just now, what is important to us will be this column. And the next one I need to decide is this one. In my case, normally because all of you are doing multiple regression, isn't it? You will use scale. Only the case of adoption of BNPL, the DV will be nominal, but that is the next test. You don't use this test, logistic, totally different step, okay? So I have set my variable view. So once I'm okay with this, I click on my data view. You notice it will first come out the variable name, and this one is, it will continue until how many number, then I key in. So as I've advised you, when you key in by variable, right? And then the total score, right? So meaning there could be quite a number of column, right? Okay, so you key in accordingly. And then you must do your diagnostic testing, right? So meaning if we compare, where are we for primary data, we have learned how to generate descriptive statistics. For profile of respondent, actually you can generate the same thing. If I didn't show, I think you can, because in my example here, I didn't key in any profile of respondent, but I think you can find the same under descriptive statistic. So you ask them to generate for the respondent, the data, right? But I will show you what to report later. I have shown you normality testing, right? But now what I want to show you is here, normality testing done. So what we haven't shown is reliability test, correlation analysis. Okay, so we are going to do these two tests now. Reliability test, meaning what we want to generate is the Cronbach alpha. Okay, so Cronbach alpha, these are the steps, but actually you can see here. I will click analyze, scale, reliability analysis. The moment I click that, it will come out this window, right? So I will choose whatever I tick, you tick accordingly, okay? Right, and then I think it will go to, oh no, then straight away I think continue, then okay, right? But this is the part, right? What am I going to, here it didn't show, what am I going to choose, right? To go into my scale and so on. You see, I show it through the concept here. Remember just now I say key in for by question, isn't it? Let's say this is one of my IV protein, but I will choose, just now for all other tests, I will choose the combined score for protein. But here, Cronbach alpha, remember, I want to see the consistency for every question on my variable, right? How consistent is the score? That's why this is the part why I need the breakdown of the question. So here, what I do is I will select, like in this case, I want to generate the Cronbach alpha for protein, right? How many Cronbach alpha you need to generate? You need to generate, this is the part I think I didn't write down. You need to generate the Cronbach alpha, right? For your DV, for your IV, each of your IV, and then one is the combined score, okay? So meaning, you have 1 DV, 5 IV, meaning there will be 6 Cronbach alpha score. Then one more is combine everything, right? So meaning I will see 7 Cronbach alpha score. Okay? So like I want to generate the Cronbach alpha score for protein, one of my IV. So I have to select all the breakdown of the questions to go into item. I think here, because I didn't show the print screen, I think, right? So, but how you do it in concept, after I come to this reliability analysis, they will ask you to choose one, the item. So like if here I want to generate the reliability score for protein, I will select all this and I think I will put it as item, right? And then I will click scale. I will click scale if item deleted. Okay, so here I have a summary table. How many Cronbach alpha I need to generate? In my case, because I have 3 IV, 1 DV, so I need 4 Cronbach alpha. As I've mentioned, you could have one more combined one, meaning for everything, right? And here I must report number of items. Number of items means actually number of questions. Like just now, protein, I assume in my questionnaire, I have 6 questions asking about protein. So meaning my number of item will be 6. So how does software know 6? That's why you must key in by question. Then they know, there are 6 questions measuring protein, and this is the Cronbach alpha. So you do the same for the rest. Now, after you get the Cronbach alpha, I've mentioned before, how to interpret the score. If the Cronbach alpha is more than 0.7, then it's considered as good reliability. But what happens if your Cronbach alpha is less than 0.7? Here I want the students doing primary data to search further. If you look at journals or statistics book, they don't just put 0.7. They might put a range, meaning if your Cronbach alpha is between what range to what range, considered how good is the reliability, right? So the range will provide better breakdown. But the general cutoff is 0.7. So meaning if any of these is less than 0.7, meaning there's less reliability. And normally it's because your questions, as I've mentioned, they may not be testing on the right concept. That is how I evaluate how good are your questions, the quality of your questions. Okay? Right. So that is reliability score. So it's quite easy only this one. Okay? And then for correlation testing, remember for correlation, you want to test 2 things. You want to do your univariate analysis and to test for multicollinearity. So how to generate the correlation analysis? Again, we go to SPSS, analyze, correlate, bivariate. Okay? And then you click, okay, what do I click? Right, I choose everything, right? Everything, this is my IV, DV, everything. How you choose? You click one arrow key, it will go to variable. So I will select everything, right? And then move it here. Now, along the way, you see there are certain things that are ticked. I believe they are by default, but you just check, make sure they are consistent with what I show you here. Okay, right. So we click accordingly, right? And then I think nothing else, you click OK, right? The last thing to click will be OK. So it will generate this table. This table is the correlation coefficient table. Okay, so but this table, you see, got so many layers right? How to interpret it? Again, we are not going to copy and paste the whole table, right? But what I will report, I will first look at, let's say my first IV is protein. I will first report all this, okay? So all these are my correlation coefficient. But you notice some come with star, asterisk, if you enlarge it, you notice for some of the correlation, there are 2 star, some got 1 star, right? So here, what does the star stand for? 2 star means the correlation is significant at 1%. 1 star correlation is significant at 5%. Why it come out all this star? Because just now you key in already two-tailed test and you ask us to highlight, to flag the significant correlation. That's why it will show you the star. When you report in your chapter 4, please don't forget the star and then the description. Okay, I will show you later how to report this. Okay, so that is what we want to select from the correlation. Okay, right. So basically all the thing I highlighted lah, right? Meaning, just do it this way. Okay. So how to test for multicollinearity? We look at the relationship between the IV. Remember, in my case, my IV are here. Because time required is my DV. So I will look at whatever I put in gray here, right? All this, right? So I make sure the correlation coefficient, right? The guideline is if it is more or equal to 0.8, then we got problem, multicollinearity. If less than 0.8, no multicollinearity. So again, you look at all the thing highlighted here, the correlation, none of them, one is of course, why this is 1? Because protein, correlation with protein, of course, must be perfect lah. Your correlation with yourself must be perfect. So this 1, we just report, but we don't say you got multicollinearity, right? But we look at, for example, between protein and antibiotic, 0, right? Protein and other supplement, 0. So we say, in my case, there's none of the correlation between the IV that is more or equal to 0.8. So we got no multicollinearity. Okay, so that is how we test for multicollinearity. Okay, right. This one, nothing much. This one you don't report this way. This is nothing much, right? Okay. So meaning what I've shown you so far, I've shown you for primary data here until all this. Okay, right? So now what is left will be the regression results. So meaning you descriptive statistics, demographic profile is reporting only, but this one, normality test, reliability test, correlation analysis, as I've mentioned, you have to make sure it passed the test. Like normality, if you see not normal, you have to detect for outlier. Reliability, rightfully lah, if normally lah, you can do it over a longer time. If any of your Cronbach alpha is below 0.7, we have to look into the questionnaire and see how to improvise it. But because you have very limited time, so you just report only like even 0.5, just report and comment accordingly. That one, I give you some leeway lah, right? But the correlation I've mentioned, if there are multicollinearity, either you split the model or you drop. I don't think for survey you can drop anything. So you just split the model, okay? So after it passed every diagnostic testing, finally, we can run the regression analysis, okay? So next, we want to run the multiple regression, bearing in mind, this is my conceptual framework. I got 3 IV, 1 DV, okay? So the next step is the multiple regression, okay? So far, are you following, class? Are we still okay? Okay, no more response already, Right. Do you need a toilet break? Shall we take a 5 minutes toilet break? Yes, I think we are sitting here for 5 minutes toilet break. So now to me, it's going to be 6:49 soon. So come back at 5 minutes means what? 6:54. Okay, correct? 6:54.
Miss, I have a question.
You have question. Shall we ask after the toilet break?
Okay, sure.
Right. Sure, right. I think everybody wants to go for your toilet break. So I put down here, come back at 6:54. p.m. Okay, then I will open up for some questions. Okay, is everyone back? Are you back, class? Can I have some indication? No one is back. Okay, right. So, okay, I think before that, we got question. Is it? Hold on. Who raised up the hand? Nicholas, is it the one you type on the chat box, man?
Yeah,
you want
actually,
to-
about
You're
dividing the model.
All right. Okay. No. What you divide the model could be, let's say, like what you put in the chat box, the correlation between your IV1 and 2 is more than 0.8, isn't it? So how to split the data? Meaning, remember, you're running the regression between your DV and the IV, isn't it? Right? So could be you run, really, we have to see how you arrange it in a way that it will look presentable as well. Okay? Could be you will run, meaning you can run 2 regression, but make sure you have 5 IV, isn't it? You run 2 regression, but make sure your IV1 and IV2 are not in the same regression. So what can you do? For example, in the first model, you put your DV, IV1, you can put your IV3, 4, 5, but you exclude IV2. You understand what I mean, Nicholas? And then the second one, you run your DV, IV2. It depends. If you want to repeat IV3, 4, 5 also can. If you don't want, it depends how many are highly correlated. Also, we have to be very careful with presentation, because should we run every IV separately so that they look consistent? Should we split it to 2 and so on? We also want to see later when we present the results, will it look very strange or not? Okay, you understand, Nicholas, what I'm saying here?
I think so.
Yeah, so it is a matter of judgment also, so that it doesn't look like why one model got 1 variable, why the other model got 4 variable, So we have to use our judgment as well. But the main thing is, in the same model, you cannot put both IV1 and 2. Okay, right? As long as you split them, how you present them is a matter of presentation, whether it's nice or not nice. Okay, right? Okay, Sanjana have a question. Survey 300 people. Must be those who fit our criteria, or can we be done with the survey? It must fit criteria, Sanjana. If they don't fit your criteria, you shouldn't even consider them as respondent. Understand, Sanjana? Of course, you're going to give out to a lot of people, but they must meet the filter test. They must fulfill the filter questions, right? Meet your criteria. That 300 final one that fulfill your criteria are considered your respondents. So Nicholas say, yeah, you can have 400, but only 300 qualified. Yes. So we based on the 300 qualified, not the initial 400 that we sent out. Yes, that's correct. Okay. Sanjana, you understand? She posted the question. I hope. Okay, Sanjana say, can you include the pilot study if they fit the criteria? But the danger with pilot study, remember, because pilot study, based on the pilot study, the respondent of the pilot study may have some comment about your questionnaire, right? So you may amend the questionnaire later. So meaning that initial questionnaire shouldn't be the correct questionnaire. So if you're going to amend the questionnaire later, then you cannot use the answers given by the pilot study respondent. Okay, it must be based on the final questionnaire. Unless you amend the questionnaire after the pilot study response, you give it back to the 30. Then it's okay, right? So it must be based on the final version of the questionnaire. Okay, Sanjana, you got that? Can, right? Okay, any other questions before we proceed with the multiple regression? No, right? So I'll proceed, right? Okay. So, final step, analyze regression linear, because we want to run a linear regression. So this part is very simple. SPSS is a very friendly software. So what we do, remember here they ask you to choose which is dependent variable, which are independent variables. So in our case, time required is dependent. The first three are independent. So again, using this arrow, I click here, protein, I click the arrow, so it go into IV. So ultimately, this is step by step. It will look like this, the final one. After I shift everything correctly, make sure you put it in the right DV and IV place. Okay? So after I do that, nothing else already lah. The rest, you just check lah. Make sure you put it the right way lah. So okay lah, click OK. Then the final output, right, will be like this. But again, SPSS like to produce many tables. So which one are useful for our reporting? I've highlighted. Number one, remember I've mentioned we have to report R square. In my case, my R square is 0.901, meaning if you convert to percentage, 90.1%, right? So if based on decimal, 0.901 is close to 1. So my model fit is good. So I'm going to report this, and I can report like just now based on my slide. So 90.1% in the variation in my DV can be explained by my IV. So it's a very good model, right? I put in the right regressors or the right IV, okay? So I will report this one. Just now, I've also talked about F statistic. You can also include that as an additional indicator of the fitness of the model. So here, F statistic you will report, but it has no good meaning one. The meaning is in the significance. Significance is the p-value. So here, I've given the guideline. If the significance of p-value is less than 0.05, like in our case, 0, meaning the model fit is good. If it's more than 0.05, meaning it's not a good model. Okay, we can also add this into our interpretation. Right, the most important table is this one. Okay, right. So what am I going to report? First level, I will report whatever I've highlighted in yellow. Second level, I will report the blue one. Okay, so first, I will look at unstandardized coefficient. If you remember, coefficient is all just now your B1, B2 lah, right? Okay, so you see I have my constant, which is my B1. Then I have a B0 lah. Normally we put B0, isn't it? Then I have B1, B2, B3. So it comes out this way. And then significance are the p-value. You can see, oh, my significance is 0. 0 means significant at 1%, meaning it's very good, very strong. Okay. So what does it mean? So to me, what it means, interpretation, you can get some guidance here, but later, the final interpretation you follow based on my student sample, right? Okay, but here you can get some idea, but don't report like this in your project paper. This is more when we study our statistics class or econometrics class, we show it this way. But project paper, you report according to my sample students' work. So you can report your F value, right? P is 0. So this is the F statistic. The P value is significant at 1%. So the model fit is good. R square is 90.1%, meaning 90.1% of variance in the DV, time required, can be explained by the IV, which is the fit additives. So in my case, for my 3 IV, you can see all my 3 IV are significant, right? These are my 3 IV, all significant at 1%, which is very good, okay? But also take a look at my unstandardized coefficient or unstandardized beta. Look at the sign, very important. All 3 is negative sign, meaning we are saying there is a negative and significant relationship between every IV with my DV, okay? So meaning when I report, the important thing will be, I will report for every IV, the sign, negative. the p-value is significant at 1%. Okay, but how to report it properly? That is the next level when we put it into the proper report. But we are saying all three are significant. We don't know, but I think our hypothesis, did we put our hypothesis? You have to refer back to your chapter 2, right? Is your hypothesis positive or negative? In this case, all the results turn out to be negative and significant. Okay, this one, don't report this way. Okay, forget about this one. I unhighlight it. Don't need to report this way. Okay, so that is first level of analysis. Now, second level, we can look at the standardized beta. Standardized beta, you can see, we will base on the absolute value. Absolute value means we forget about the negative sign. We just look at the value, ignoring positive, negative. We rank. The highest value means that is the most important IV. So if we get rid of all the negative sign, the biggest value is 0.711 protein, followed by supplement, and then finally antibiotic. So meaning I can do a ranking like this, okay, to show the relative importance of the IV based on the absolute value of my standardized data. So like what I've mentioned, protein, if absolute value, meaning all change to positive, is the highest importance, followed by supplement, and the least important is antibiotic. So you can also interpret the relative importance of each IV. But remember something, this is second level analysis. Whatever you consider must be in the first place, in the first level, they must be significant. So meaning mine, all three are significant. That's why I can go to second level, rank them. But what happened if, let's say, I change the story. Only protein and antibiotic are significant. Supplement not significant. Let's say come out, this one 0.2. Oh, 0.2 is more than, meaning 20%, more than 10%. Supplement is not significant. So meaning when I do based on my standardized beta, I must only consider the first two. The one not significant, don't even bother to rank it because it is not an important variable at all. Okay, so you must make sure they are significant first before you can rank them accordingly. Okay, so that is multiple regression. Okay, but of course interpretation, there are more requirement lah. That will be the next next level lah when we interpret the data. Okay, so that is for most of the survey lah, right? Any questions? Not at the moment. Okay, then I will go to logistic. Logistic, as I mentioned, actually only one group lah that I can remember, Pinlin's group for adoption of BNPL. So logistic regression, right? The nature will be the DV is non-metric because nominal, categorical, adopt, do not adopt. But the IV is all based on like 5-point Likert scale. That's why it is scale. Later we put it as scale. Okay, so example, right? We want to predict if a person is healthy or not. You see the DV, healthy, not healthy. Just like what the group is doing. Adopt, do not adopt. So that's why my DV is categorical, or we call it nominal, based on the ESR rate. And the predictor variable, predictor again is another word for independent variable. So the IV use got 4, fibrogen, gamma, globulin, 5, age and weight. And I based on 32 respondent, my patients. This is a medical study, okay? So again, I collect all my data. So all these, 5 or 4, why look like 1? Oh, gamma globulin is 1. Okay. 1, 2, 3, 4. Okay, so I have 4 IV, then healthy or not is my DV. So you can see the DV look very different one. It's categorical, yes, no. Healthy, not healthy. Okay, so the rest for IV is just like for the multiple regression. We will add up all the score from the 5-point Likert scale and we get all the score. but the DV can only take two values, 0 and 1. Which is 0, which is 1, you decide. But normally, like adoption, adopt 1. Do not adopt 0. So you see the value can only take 1 and 0. Okay? Right. So this will be the conceptual framework lah. Right. Rightfully is 3 lor. I don't know why end up 4. Just now we say, isn't it? Which one? Is this the same framework? 1, 2, 3, 4. Yeah, 4. Okay, right. Maybe tired already. Yeah? Right. 4 IV, 1 DV. Okay, right. So here, our hypothesis, we say all the 4 IV is positively, have positive relationship with our DV. So we want to test is this true or not? Okay, right. So same process. I will first go into variable view. For the IV, the same, the scale. But the DV, health, we put nominal. So once you click nominal, another table will pop out one. They will ask you, because nominal, they will ask you to designate the value. Value means what? In our case, healthy, not healthy. So you must assign 0 and 1. For this example, the researcher put 0 as healthy, 1 not healthy. But normally adoption, we will put 1 is adopt, 0 is do not adopt. So you have to label it accordingly and make sure you label correctly, because later the results will follow your labeling. Okay, so once you're done, it will look like this, right? To confirm this is correct, then okay. So again, after that, you go to your still variable view. After you do that, you notice this part, if you drop down, it will show 0 healthy, 1 not healthy. Okay, then we can go to our data view and you key in accordingly, like how the multiple regression does it. Okay, except the healthy part is only 0 and 1. Okay, so the same thing. Regression, the regression part will look different, right? Other tests, no difference. Your other tests, meaning you test for normality, reliability, correlation, all the same. So I won't repeat, it's the same thing. Only the regression part will be different. So I will zoom into the regression part. So here, regression, instead of just now choosing linear, isn't it? I will choose binary logistic. Okay, so, and then again, they ask you to choose which is dependent, which is covariable. The covariates is the IV. DV is health law. The rest will be covariate, meaning your IV. So it will look like this. Okay. So once you have it, okay, not yet. Okay. You click the rest. You follow only lah, right? Here you can see how do I go to the next one. I click options. If you don't know what to click, you can see the top there, it will show what did I click to come to this window option. You click according to what I click, right? And then what else? Then I think that's it. Option, I click option, then nothing already. Then I click OK. Finally, OK, right? So after that, the tables. You notice the table come up for logistic are very different one, right? First table, what we're interested to see is what is included in the analysis, any missing data. Remember, we have 32 patients, so the report say, they did consider all the 32 patients, no missing cases, so confirm correct. Like your case, 300 respondents and nothing should be missing, okay? So then we confirm, we input correctly. And then again, they want you to confirm what is 0, what is 1. This is the one we label. But remember, for your case, normally adopt is 1, do not adopt is 0 lah. Okay, right. So, but all this is just for our checking. The first thing that is important for reporting will be this classification table. You will notice when you generate this, it will come up 2 classification table that look quite the same, but the statistics may be different. So I call this as the first classification table. The first table, what I'm interested in is the overall percentage that is correct, meaning this 71.9%. Why? Because this percentage correct in this first classification table will represent the percentage threshold, meaning this is the minimum benchmark that I must achieve later on when I generate the second table. Okay, so this is the minimum threshold. I remember this. Later, my benchmark is 71.9%. Okay, meaning my threshold or my benchmark, I aim that my model must correctly classify at least 71.9% of the patients. Okay? And then it will generate more and more table. But what we want to see next is this table. I'm interested in these two variables, Cox and Snell R-square. It is like multiple regression, your R-square, but they have two different R-square. Just now, we have only one R-square. For logistic regression, got two different R-square, but they're testing the same thing. Is the model fit good or not? Okay, so we have two R-square here. And then they have something called Homer and Lemaitre test. All these three are important, but we have to calculate something based on this. Later, I will show you. Right. And then we go to the second classification table. Again, what we want is the percentage correct, 87.5%. So what am I going to do with all that? Not yet. One final thing, this is the final one. Right. We are interested to look at which variable. All these are our IV. We are interested in the beta. The walk statistic is just to report only, but what we want is the p-value, the significance. So you can see, again, p-value based on 1%, 5%, 10%. Only fibrinogen and globulin, you see, is less than 10%. Whereas age and weight already more than 10%, so consider not significant. Unlike just now, all are significant. Here, only the first two IV are statistically significant. Okay, so what do I do with all the results that I've highlighted? So this is just to give you an idea. What I will put in my logistic regression is a bit special. So you are going to report all this, right? But in proper reporting style. I will report my table 2. This is based on classification table 2. If you notice, table 2 is this one. I copy again, but I produce it maybe a bit nicely. So threshold percentage is from table 1. If you remember, 71.9%. Okay. Then I will report my 2R-square. For Homer and Lemaitre test, remember just now I highlighted my chi-square and my DF is degree of freedom. But I will take my chi-square divided by degree of freedom, and you see what I get is 0.6679. So as long as what I get is less than 3, consider it is okay. Okay? And not only that, I must see this Homer and Lemaitre test, the p-value must be more than 0.05, then it's considered okay. Less than 0.05, not okay. So what is okay, not okay? Let's see how do we interpret this. Okay. So the regression model I use is binary logistic regression model. Binary means only got two lah. Like here, healthy, not healthy. Only two options. So you can write something like this. This one, you can follow something like this. I will talk about my table 1 results. My table 1 is the one I reproduce. It's actually classification table 2, right? So I've mentioned here, I produce the results of my test in table 1. And here it says how I interpret. The results indicate that the predictive accuracy of the model is 87.5% here, right? And the threshold is 71.9%, which is good lah, because minimum I need to predict correctly only 71.9%. But in actual, it is higher. I predicted correctly 87.5%. So my model is a good one. Then you can talk about the R-square, right? You just mentioned like how I did for my R-square just now. In terms of how much it captures the variability in my DV. But for Homer and Lemaitre, this is how I report. Right. Why the test is good? Because just now we say, right, we get less than 3 and then the p-value is more than 5%. So meaning the results is good. And this, what does it show? It is also the test that the model is, the fit is good, okay, together with the 2R square. All right. And then what else do I have to report? Then finally will be the results. So as I've mentioned, only 2 variables are significant. Fibrinogen and globulin. Okay. So, and then look at the beta is positive. I remember just now my hypothesis is positive. And now for these 2 IV significant. So meaning in terms of H1 and H2, these 2 are supported. But H3, H4, because not significant, so we don't care whether the sign positive, negative. The moment the p-value is more than 10%, we say there is no relationship. No relationship means it doesn't support our hypothesis, because our hypothesis always say there is a relationship. Okay, so meaning only the first 2 hypotheses are supported, because there is a positive relationship, and then you can report significant at what percent. Okay, like in this case, okay, let's see whether I have it here now. Here, I didn't mention significant at what percent, but you can choose 1%, 5%, 10%. So fibrinogen is significant. Same with globulin. Okay, but reporting, later you follow the student sample. But this is just the idea of what is important to report. Okay, so that is logistic right? Okay, so I hope I explained this. Pinlin's group is here because that is specially for them. Is Pinlin's members here? I should have asked that first, right? Yeah, they are here. If they are not here, then I say skip, study yourself, right? Any questions? This is Pinlin group only. You digest first, right? If you got question, you ask. So I will go to eViews now, right? Because I think 50% of the students are using secondary data, right? So finally, on eViews, so let's say we have this model specification. Ln, it means my natural log. Remember when I told you to give me the formula for each variable, you notice sometimes we use natural logarithm, especially if the value is very big, like total assets, isn't it? So make sure if those formula has natural log, you make sure you log it. It's not there for show only. You must log it accordingly. Now, how to log it? I will explain shortly. You can see in my case, all have to log, but not in your case. Yours, you follow back the literature. Normally, we only log for those big value. For ratio, normally we don't log one. Okay, but this one, you just take the model as it is. So I have 1 DV. Some could be my IV, the rest are control variable. In this case, we don't care. All we call this as our IV. Remember, for secondary data, this part will include your IV and your control variable. Everything must go into the analysis. Okay, so some of you ask me how to arrange the data. We will start by arranging the data in the Excel. Okay, but I will show you based on this. You can see how I will stack my data, right? Let's say I'm doing 100 companies, isn't it? And I'm doing from year 2003 to 2011. I hope you can see. I make it bigger. Right? Let's say I got 100 companies, the study period 2003 to 2011. So I will start off with Excel, right? Every company, I will give it what I call as an ID, right? ID is like an identification number or code, right? So you must know your company. Maybe first company, Air Asia, I put 1. Second company, Ajinomoto, 2. So you decide by yourself. So normally I will label from 1 until 100. So I know this is company number 1. Okay, right. But make sure on a separate worksheet, you know, one is which company in case you have to trace back. So then what I do, you see, I arrange company one. Let's say this is Air Asia. I put one, then I put the year, meaning all these are for Air Asia, the first company. Then I will put my DV, IV, and all my control variable. Okay. Then I repeat the same process for the second company. Let's say Ajinomoto, company number 2. Same thing, must follow the same year. 2003 to 2011, same thing. I input everything. Then year 3, and company 3, company 4 until company 100. Okay, so I think for some student I have mentioned before, if yours is a ratio, let's say like ROA, put it in decimal. Decimal meaning 0 point something. Don't need to times 100. Don't convert it to percentage. Leave it in decimal places. How to create log? Your log, natural log in your Excel itself already convert whichever need to be converted to log. Log very easy one. You click on the cell. This is not a real Excel, so I cannot click. You will notice that you click LN. When you click LN, you can try your Excel in my chat box. When you click LN, you notice the Excel will show you there's a formula LN. So you just click, okay lah, you want this LN function. LN is the natural log function, right? Then convert all your total assets into natural log this way, right? So that is how you convert to log. So everything log, everything in ratio ready. Later, we will copy and paste this into Excel. When I copy and paste, you can see there's a square box already. I'll put it smaller. When I copy and paste, I copy only the variable name and the value. I don't need to copy my ID and year. eViews will create it for me. So you see, I only copy and paste this one all the way to 100 firm, right? Later, I will paste into eViews. Okay, right? See, copy lah, right? I click copy, then I hold on to it. Then I open up my eViews. Now, eViews now, I think already version, I think at least 12 or more. When I prepare this, mine is quite old, eViews 8, but the functions doesn't change very much. Same with SPSS. Mine is the older one. It doesn't change that much. So still can refer to it. Right. So when I click on my eViews, first thing, I have to click this one. They will ask you what you want to do with the eViews. I will click on create a new eViews work file. Okay. Once I do that, right, what do I do? Right, I think it's either this or this. I think it's the same thing, right? Either you do this or alternatively this one. You click file, new work file. I think it's the same function alternative way. But whatever it is you do, it must come up to this window. They ask you what you want for your new work file. Because for our case, all our panel data is balanced. Balanced why? Right? Because I think I asked all of you to make sure for every company, you must have data for every year. If any company has incomplete data for any year, we don't want that company. So if every company have the same number of year, the data set is complete, that is called a balanced panel, right? So that's why here, I will click on balance panel. But you notice later on, I will show you, if you click on, I think, undated, it is still okay one. The results will be the same. So you actually have two choices, okay? But I click on balance panel first. Frequency depending on your data, right? If you have to see your own Excel. If your data is annual, then it's annual. If you are using for whatever reason, I cannot remember. If it's daily data, stock prices, or monthly, then you click the correct frequency. But whatever you click, I know some from monthly, daily, you convert to annual. But when you put here will be the final one, annual. But if all your data are daily and you maintain daily, for example, then you click daily. Mine is annual. As you can see, you need to click in start date. Mine is start year 2003, end year 2011. Number of cross section is how many company. My case, 100 companies. Okay, so once I do this, I click OK. So okay, you notice this screen will pop out. Now there's nothing to do here, but what I want is I want to click on this quick empty group series. I click on it. Once I click on it, it will come up with this empty worksheet. Right. This empty worksheet, you notice it already labeled for me this way. 1, then 0, 3 until 11. What does it mean? It means 1 is just now my company, the ID 1, like Air Asia is just now, isn't it? My first company, 0, 03 is the year. Remember, my year start from 2003 and 2011. So it's actually capturing the year from first company, 2003 until 2011. Then it go to the same thing, second company, third company. So that's why just now when I copy and paste, if you remember, I don't need to copy and paste these two columns because eView actually created it for me. That's why I only need to paste the variable name and the actual data. Now, how do I paste? This is a bit trickier if you haven't used eViews before. When I'm on this worksheet, you notice, actually my first data should start 103. First, when you click on this empty group series, you must scroll. You must use your mouse, scroll, and you notice it will show you this extra row. If you don't scroll, you notice what you see is starting 103, meaning this extra row up here is hidden. But when you scroll, you notice it will reveal there's one additional row. And you are going to paste like as if I'm pasting something, my data into this first cell here, the one I highlight in yellow. Okay? So I will click on this cell, this empty cell here with no numbering, anything, paste. So when I paste, I will get my variable name and all the data. Okay? Just like your Excel. Okay? So once I have this, what do I want? Same thing. I go back to my checklist. Panel data. I need to generate descriptive statistics, right? So descriptive statistics. I go to view, descriptive stats, common sample. Okay? And common sample means what, It will include all the variable automatically. Individual sample one by one. Don't waste your time. Click common, everything cover. So okay, once you click okay, it will come out this table, right? With all the variable, then your mean, median, all the descriptive statistics. Now, you may not want to key in everything, right? So there's one way you can copy the table, but later, as I say, you still have to present it according to the prescribed style, but at least maybe you don't want to type back every single thing. So can you actually copy this and paste it into your report? Yes. So what you do is you highlight, meaning I will click, now I can't click, it's not a proper software. I will highlight, you notice in blue, the area I want to copy. And I think what I do is my right click on my mouse, copy. Then I will choose formatted. Then I press OK. Right? Then I will choose my Microsoft Word. Like maybe this is your real report. I will just press paste. So it will paste like this. Okay? But later you see, I don't need all the data. Right? Normally what I need is the mean, maximum, minimum. Again, like similar to SPSS, standard deviation, observation. All the other data, I don't need it. So I don't need to report everything. Okay? Right. So, done, no? I did for descriptive statistics. So next, what else I need to do? I think now I'm going to correlation analysis, isn't it? Correlation. Okay. Correlation analysis is to test for multicollinearity and also for univariate testing. Again, view, covariance analysis. I will have, once I click on covariance analysis, it will come to this window. You follow only, whatever I click, you click accordingly. Then okay. So I will get, you see the table I get, the correlation table, the concept looks the same like SPSS, right? Okay, again, I can copy and paste it into my Word. Same thing, I highlight the area I want and then copy, formatted style, then paste. So similar to what I've explained for SPSS, what I will report will be the one highlighted. The highlighted one is the correlation coefficient, okay? But what about the star? Just now got star, isn't it, for the SPSS? The star is indicated, they didn't indicate directly, but the bottom value here, all these are p-value. So you can put, for example, later I will show in my report. One star, normally p-value, maybe I put some, where to put. Later you see we have a system one. P-value, if 10%, I will put normally 1 star, 1 asterisk. I put into the chat box. Normally, if my P-value is 1%, right, I will put as 3 asterisks. If P-value is 5%, means significant at 5%, I will put 2 star. If my P-value is 10%, I will put as 1 star. So you notice, if you read journal, at the bottom of the table for the results, they will always indicate 3 star, 2 star, 1 star. And this is the standard measure, 1%, 5, and 10%. So you can do the same for this table, right? The actual reporting will be based on my students' work. But how to know how many star? You look at this. 0 means significant at 1%. So meaning I will report this, but I will put 3 star. I don't put 0.000. I will put 3 star next to here. So if anything else, like this one, this is significant at 10%, isn't it? Because here is already more than 5%. So I will copy this. I will put 1 star. That is how I will report my correlation table. Okay, how to interpret same thing? We look at all our IV. In this case, I got so many IV and control variable. Meaning I will look from here to here, except the first column, that is the DV. I make sure my correlation is less than 0.8. If in our case, you see, if you look carefully, all are less than 0.8. So there is no multicollinearity problem. Okay? Right. So I have settled correlation, okay? But what I haven't done is normality and the rest, okay? But before I can do that, I need to specify my regression model first, then only I can do all the other testing. So I'm using POOLS, right? Because chapter 3, I've clearly indicated, right? We use POOLS. So how to instruct eViews, I want to use POOLS. I will go to quick estimate equation, right? And then this table will pop out and I have to type in the equation. How to type in the equation? This is the enlarged version of the equation. This will follow, just now remember what you key in into your Excel. This is the name of the variable. You can put symbol, you can put full name, but make sure you type in the right name. So the first one here is your DV, dependent variable, C intercept, followed by your IV and then your control variable. You must type in according to this sequence. eView will understand the first one is DV, C intercept. The rest are IV and control variable, right? So you type it into this, right? And then because we're using OLS, that's why the method is least square, right? The rest are by default lah, right? And then this one will be on this panel one. Specification. So next, I will click on the panel option. You see, panel option. Panel option, I will put none, none, and then the rest follow accordingly. Anything else? Oh, nothing else. Then I will click OK, right? OK. So the moment I click OK, it will come out with this. This is the preliminary regression results. Preliminary means what? It hasn't passed all the diagnostic tests. So this may not be your final results. Okay, remember, you cannot so happy say, oh, this is my final result. No, this is just the preliminary result. We haven't tested for other diagnostic testing. But again, if let's say you want to copy any result, same thing. You highlight the area, copy, formatted, then you paste into your Microsoft Word this way. Okay, but I will just explain right? If let's say this is the final result, what you will look at, but remember, you haven't passed all your tests yet, right? I will have to report number of observations. In this case, 900. Why 900? Because I have 100 companies, if you remember. Why 900? Because I have 100 firms, and 2003 to 2011 are 9 years. So 100 times 9, that's why I got 900 firm year observation. Okay? Right. Right. And you see it will appear, C is the intercept. These are my IV and my control variable. What I'm interested in is my coefficient. Coefficient is your beta lah, beta B1, B2, B3 until the end. So what I want is the sign, isn't it? To know it's negative or positive relationship. Probability. Probability is your p-value. You can see SPSS use SIG, significance. Here we use p-value. So same concept, no? Like you see, you will still report intercept, but you don't interpret. Like log total asset, significant at 10%, because this is 8%. Here, all this significant at 1%. This one, significant at 5%. But these three, more than 10%, the last three, so not significant. Okay, so that is how we interpret it. And what else we want? We want the R square, F statistic, and the p-value. Another thing we want to observe is the Durbin-Watson. Durbin-Watson, if you recall just now, is a test for autocorrelation. And Durbin-Watson, rightfully, if no autocorrelation, the value should be, cannot type, the value should be 2. But here, preliminary, we see we got a problem already. The value is way below 2, so we know we have autocorrelation problem. Okay, we have to solve it later. But remember, this is not the final regression model. We need to pass all the diagnostic tests first, right? But if this is the final model, remember, these are the things we look out for. Okay, so I do all the diagnostic testing lah, right? I will test now for normality. How to test for normality? I will go to view, residual diagnostic. I will choose histogram normality test. And I will come out with this. Okay, right. So remember, this one is after you key in the whole full regression, the equation already. So what is tested here is the residual, the error term, right? And what we want, remember, normality test for E-views, just now I mentioned, we look at the Jack-Barra test. So now, this is the Jack-Barra test. Okay. So how to look at the Jack-Barra test? The statistics is not important. What is important? Probability. Probability is the p-value. So the guideline is, if the Jack-Barra's p-value is less than 0.05, not normally distributed. More than 0.05, not significant, then it is normally distributed. In my case, wow, 0. So not normally distributed. So actually, I have a problem with normality. I must solve it, like just now I said I should detect the outlier and so on. But here I didn't do it. I didn't do it. So rightfully, I cannot proceed until I solve it. But assume I clean up, I solve the problem, I rerun, then wow, I rerun the Jack-Barra, then normal. Let's say you must pass the test. Then only I proceed to the next test. So this is not a very good example. I must pass the normality test, then only I can do the next test. Heteroskedasticity. Okay, right. Assuming I pass the normality test, now the problem with heteroskedasticity, remember just now, when I am at the initial work file, I click on balance panel. When you click on balance panel, we got a problem. The heteroskedasticity test come out is not like the one you normally, not the type we want, okay? So that's why to solve the problem, so that we get back the normal heteroskedasticity test, here, going back to the initial file, you create work file, just like how you do at the beginning, but I will click in unstructured or undated instead of balance panel. So meaning actually, if you don't want all this hassle, you don't choose balance panel. Straight away, you choose unstructured or undated. Why I show you balance panel? Because actually our data is balance panel. We could have used that option. But when it comes to heteroskedasticity testing, it is not so ideal to base on the balance panel setting because the tests come out are very different tests, right? So especially those who learn econometrics, you are more comfortable with the one that I'm going to show you. So what I'm saying is, if you don't want to choose the balance panel, you can choose this alternative. Go straight to unstructured or undated panel. The results are the same one. I will show you the results will be the same. But here, you notice when I click on undated, I won't have like just now, you see the screen is different. They just ask you how many observation. How many observation will be firm year observation? Like I shown you just now, 100 firm times 9 years. You must calculate yourself, 900 observation. Okay. So the same thing, I go to empty group series. You see, I'm repeating the process, but using an alternative work file. Same thing, I go to the first cell here, right? And then I paste my Excel value, right? Right? I copy all this from Excel and I will paste it. But you see, what come out at the side is a bit different. Just now, because balance, it have 1, 0, 3 until 1, 11, 2, 0. It's stacked just like your Excel. But undated, it won't. It will put from number 1 until 900. But don't worry. The Excel still understand. Meaning from 1 to 11 is company 1. The Excel still understand. 12 to plus 11, right, is company 2. They still know the sequence, which data belong to which company, okay? But when you do it this way, you can do the same thing. Estimate equation, same thing. I key in the equation. You notice the results now may be very small. You compare back with just now the results using balance panel, it is the same. So meaning you can use 2 different alternative work file, okay? But if you use the undated one, we can do the normal heteroskedasticity test that if you have taken econometrics, this is the normal one. We go to view residual diagnostic heteroskedasticity test, okay? And they will ask you, Which test? That's why I say there are many tests. So my preference here, I will use the white test. I click white test, then okay. I will get heteroscedasticity test based on the white test. So the only thing I'm interested in this super long table is only this column. Observation R square, this statistic, I'm not interested. I want the probability chi-square. Probability chi-square is like the p-value. So I want the p-value. In this case, is significant at 1%. So how do I interpret this? If the p-value is less than 0.05, meaning significant, meaning there is heteroscedasticity problem. If more than 0.05, meaning we do not reach, we say that H null is the correct one, then is homoscedasticity, no hetero problem. Okay, so in my case, it is 0, less than 0.05, so significant. So I have hetero problem. So when I have hetero problem, I must solve the problem first before I go to the next step, which is autocorrelation. How to solve the problem? There are many ways to solve the problem. That's why if you look at my video, not my video, the video I've uploaded to your Google Classroom, they give you different way, right? But I'm just showing you one of the way. It may not be the way that works for your data set, but I'm just showing one way. One easy way, like the one I shown in the slide, I use the white robust test. So I will click, cannot see, this is, I think it's under estimate, right? Estimate, then go to equation estimation, right? Under option, I click white. Okay, then okay. So you will see it will regenerate my results, but it will put there now my result is white heteroscedasticity consistent standard error, meaning it shows that I have corrected for heteroscedasticity using the white test. Okay, right. So meaning with this white heteroscedasticity consistent standard error, it is considered my data now is homoscedasticity, meaning no more hetero problem. Okay, but you notice my Durbin-Watson remained the same, still less than 2. So I solved the hetero problem, but I still have auto problem. But I want to test properly. Is it true I really have auto problem? One test for autocorrelation is Durbin-Watson. So it shows I got problem. But I want to confirm further, right? But before I go to that, so remember, for hetero-wise, what can I say? Heteroscedasticity is already corrected, but using the robust white standard error. Okay? Or I say my standard errors are adjusted for heteroscedasticity using white correction. This kind of words you can put into your final report to show that initially my data have hetero problem, but I corrected it using the robust white standard error. Okay? So meaning I have solved the hetero problem. Now I want to test for autocorrelation. Okay? So what do? I go to view, residual diagnostic, serial correlation LM test, meaning I'm going to use the LM test, the Lagrange multiplier test. Okay, so LM test, lag size, normally I use 6 lah, so I will put there as 6. You just follow lah, then okay. So again, this Bruch BGLM lah, we call it Bruch-Godfrey LM test. Again, what I'm interested in is the observation R square, the probability. P-value. Again, my p-value is significant. You see 0. So the same thing, if the p-value is less than 0.05, I have autocorrelation problem. So I have how to correct for this problem. Here is just my suggestion. This works for me, but may not work for you. That's why, depending on your problem, you have to look at the 2 YouTube video. and they give you many suggestions. You have to try lah until you solve the problem. Okay. For my case, I can correct it using second order autocorrelation. AR. AR stands for autoregressive. Second order means 1, 2 second, right? So what I do, if you notice, from here to here is my original equation. But I will add in autoregressive 1 and 2. For my case, how do I know mine is AR 1 and 2? Actually, I tried step by step. If you look at the YouTube video, it show you. We don't suddenly do AR 2 1. First, I do AR 1. I see still cannot solve my problem. So I try many things until I try AR 2. How do I do it? Meaning I go back to my estimate equation, right? Into my formula. I will add very small, right? What happened? Right. I will improvise my model, meaning I must add AR1 and 2 into my model. Meaning just now my model doesn't have AR1 and 2 1, isn't it? Here. I will revisit my equation. Now I add in AR1 and 2. The rest remain the same. So I click OK. When I click OK, oh, not yet OK. Oh, some more have, right. This one, you follow only lah, options white, because to show that I still want to remain the white robust standard error. So I follow accordingly, right? So you notice it is still white. Remember, I already corrected for hetero. I must maintain that white heteroskedasticity, consistent standard error. But now, besides correcting for hetero, I am correcting for autocorrelation when I add my AR1 and 2. How do I know I'm okay now? Look at my Durbin-Watson. Now my Durbin-Watson become 2. Remember, 2 means no more autocorrelation. So I solve my problem lah in my case. No more serial correlation because my case, my Durbin-Watson now become 2. Just now was just 0.68. But it may not work for your case. That's why you have to watch the 2 video lah and try to adapt and try whatever test that work for you lah. If you have hetero and auto problem. Okay, so you have to test accordingly. Okay. Show the SPSS website. Well, I haven't revisited for a long time. Why? You have a problem with the website, is it, Lisa? I will try. I will try. As I say, I haven't done this for a long time. Okay, wait. I go to a new window. I try it privately first. I see what funny thing come out. Anybody managed to get the SPSS one? Anybody managed to get the... There's only one trial, isn't it? One free trial, isn't it? Anybody managed to get it? Can we share? Anybody got the free trial for 1 month? Nobody? Not sure which one to use. Got many versions, meh? Let's see. Okay, I bring back my screen here. The rest all not yet try. Why? As I say, I seldom use SPSS, right? So I only use it when I have something to do, right? Okay. So I would presume I'm supposed, how can I help you? You ask them which one to use, help. Okay, try SPSS for free. Let's see what happened. Normally this, no. Normally the 30-day trial, right? For learning and support. How many options do we have? Maybe some of you can give me the input. As I say, I haven't done this for a long time. Do I need to click here? Or should I just click up there? Because SPSS is very good at changing, right? But you still must key in your data one. They will ask you for your email. They want to verify everything one. So I would think it is try for free lah. They need there. You must key in you must key in your email, right? And then you must key in the data, everything. And then there you can say, yes, I'm student. You just try lah. They will send you the verification. Then after that, from the email, then you can log in. Normally that is the case. Lisa, you understand? You have to, they need to verify your so-called your email, everything. Then they will send you the link through your email, and from there, normally no problem. When you just click in, then you can use for 1 month. Have you tried until this stage, Lisa? I think there's only one option, no trial 30 days. There's only one option available. Lisa, are you still there? Have you done until this stage? Did you fill in all the required data and send to them? Lisa, are you going to talk to me? It's 8 p.m. already. Haven't filled in. So I think it's this one, no? Right. I remember I have to fill in everything, right? Fill in everything, then wait for their email, and then from there, they will instruct you. Once they verify you're okay, then they give you the access, then you use it accordingly. Okay? Right. Any other questions? Any other questions? So it's already 8 p.m. I think 3 hours is enough. So I think tomorrow we still have lecture. So meaning you see 3 hours also we can only go to 2 out of my 3 agenda. My third agenda is the reporting. So I will use based on my student work chapter 4 to explain how to report. So it looks like I have no choice. Tomorrow still have lecture, right? Tomorrow have lecture. So I will go into how to report the results. That is important. You know how to run. You don't know how to report, interpret. You are not getting good marks as well. Okay, you must know how to present your table properly, how to interpret properly. We need that. And I will cover chapter 5. 5 is actually very short. I think 5 maybe 30 minutes I can settle everything. And I try to make it the last class, right? Because you need to know everything. So week 12, you are going to show me your chapter 4 and 5, right? So I will try to be efficient, right? And then plus some extra briefing, what else to put into your full project paper. And that should be it. Okay, so I think I will carry forward the rest to tomorrow. Okay, but are there any questions that you want to ask before we say good night? No questions? You're tired already. I think Sanjana, all of you are still are you still in the campus, Sanjana? Yes, I think they are very tired and they want to go back already. Right. Okay, so I think I don't want to. Okay. Those who want to leave, you can leave already. Those who want to stay back for Q&A, you may. Like I think my Friday group is better you start driving home. Right. Okay. Right. Okay. I saw a hand just now. Elvis, is it? Who has a question? You can ask. Who has question? Just now I saw the hands raising up. No more hand already. Any more questions? Last call? No question. Okay, so if no question, I think everybody want to cabut already, right? So good night. So I'll see you again tomorrow. Make sure you come to listen to the reporting and chapter 5. Okay? Who raised up the hand? I see somebody raised, but I cannot see who is that. Yeah, okay. Junie, yes, Junie.
We are from group 2 and
What's your title?
Our title is the relationship of global advisory and retirement planning.
Okay, right.
Since our IV is about the problem, so when we test the SPSS, is it the result come out with positive, which mean our negative relationship?
Oh, that one is you have to decide one. Meaning, rightfully your questionnaire, you have to be careful how you ask, right? Because according to your hypothesis, the more the problem, the worse the financial planning. Am I right?
Yeah.
Right. So meaning, because your IV is problem, so the higher the score means the worse is the problem. Am I right?
Yeah.
Right. But financial planning should be good one. So the higher the score means good planning. Agree?
Higher Sorry, can you sorry?
For your dependent variable, Elvis is
IIV.
okay, right?
Yeah.
So for financial planning, the higher the score, the better is the financial planning. Agree?
Yeah.
Right. So meaning, I believe all your hypotheses will be negative, isn't it? Before this,
Yeah. Our hypothesis is positive.
right? All negative, right? So meaning you have to be careful when you key in into just now the data view. When you key in the data, you have to look at the questions you ask in the questionnaire and the answer given, the 5-point Likert scale. Actually, what is it? Meaning, if the question is asked as problem, and then 5 strongly agree, meaning that is the highest problem, isn't it? So it should get 5 score lah. You understand?
Yeah, understand. Okay.
Right. So you key in accordingly, meaning the highest, if the more the problem in the SPSS, you will give higher score. For DV, the higher the financial planning, the higher the score. So meaning when the regression result come out, we expect the beta coefficient should be negative. Okay, you understand?
Yeah, understand.
Can, right, okay,
Thank
good.
you.
All right, welcome. Any other questions? Final call? I guess the rest are all comfortably at home lah, right? Any other questions? Okay, so no question, right? Maybe you need to run your data, then only you can experience it hands-on to see any difficulty or not lah. Okay, so I checked my checkbox for the last time. All right, no problem. So no problem, I think that's enough lah for today. So I'll see you tomorrow lah. Okay.